So remember, in our previous video, we talked about conditional probability rule. And so we say that the conditional probability can be written as probability of A given B. And this should be equal to probability of A and B divided by probability of B. That's the conditional probability. Now, what about multiplication rule? So we can start from here to have our multiplication rule. And all we can do here is the joint probability divided by probability of B times probability of B, then they will cancel. And it will times on this side and on the other side. So if we times probability of B for both sides, it will be like this. Probability of B times probability of A given B equals to probability of A and B. So if we times probability of B on this side, because it's divided here, so it will cancel. In this case, you can see probability of B times probability of A given B equals to the joint probability. That is actually the multiplication rule. So if A depends on B to occur, then the multiplication rule should be like this. If A and B are not related, they are independent, then we can actually multiply probability of A times probability of B. But when they are related, if one of them depends on the other, and assume that A depends on B to occur, so the multiplication rule will be like this. So these are two ways we can multiply probabilities. Now, you have seen that we have been talking about probability of A and B. So this is what we can say. It is the same as probability. It is the same as saying probability of A times probability of B, or we call it joint probability. So, and in this case, it means multiplication, but also it means joint probability. Now, if we have probability of A or B, then that means it is the additional probability. And so we can say probability of A plus probability of B. And they should be mutually exclusive and mutually exhaustive. So this OR means addition. So don't forget about AND, A and B, and A or B. This OR, it means addition, and it means multiplication. This one is what we call A union B. A union B. And here, A intersection B. Those words are important. So that's all with the basic rules of probability. And those are in our notes here. I think we have a number of examples there as well. So the next thing we're going to talk about is the relative frequency. Relative frequency is probability. So in this case, from this table, you can see that we have numbers and the frequency, how many times these values occurred. So like 0 occurred 32 times, 1 occurred 24 times, 2 occurred 32 times 3, 44, 430, and 5, 38. And so we have the total occurrence, which is 200. We're going to find a relative frequency for all this, meaning that we'll go to 0. We know that it occurred 32 times out of 200. And so we'll take 32 divided by 200, so we can get 0.16, which will give us 16%. And so the same here, you can see 1 occurred 24 times out of 200. And so we take 24 divided by 200, and so we have 0.12 or 12%. And the same with all these values. And then when you add their total for decimal points, they will sum up to 1. And when you add their percentages, they will give us 100%. So relative frequency will also give us probability, because they'll give us the percentage of occurrence of an event. And we know that the percentage is a probability. Now let's see what next we need to learn from this. So the next thing is to look at the probability distribution. And so probability distribution is a table or an equation that links each outcome of a statistical experiment with its probability of occurrence. So in this case, let's look at the variables. Let's create a variable. We could say A, B. Now this time we're going to consider event to be X. Let X be any event. And so X is our variable. So let me write here, X is, and we can write probability distribution. So in this case, let's see our variable, which is X, corresponding probabilities. So called probability of X. And so assume that X has the following. We have 0, we have 1, 2, 3, and so forth. So the corresponding probability here, we can identify any kind of probability as long as they will sum up to 1. So let me assume any values. I'm going to assume any probability values at this moment. So let me say 0.2. And let me give the last one 0.2. Well, there is no any rule that I'm following, but it's just an assumption. And I want probabilities to sum up to 1. And here, let me say 0.3. I'm just coming up with some values, 0.3. So these probabilities will be valid if we have exhausted all the possibilities and the probabilities will sum up to 1. So let me try to find out. So find the summation of all these probabilities, and so that will end up to 1. And so that's what we call probability distribution. We have values with their corresponding probabilities. What is the probability of X such that X is a particular value of X, which is Xi? And so let me change this and write Xi. So as I said here, we can say that probability of X such that X, if I'm considering Xi to be 1, so it should be 0.3. Sorry, it is 1. So close the bracket. So here we are saying probability of X such that X is Xi, a particular value of X. And we know Xi's are 0, 1, 2, 3. So what is the probability of X here? What is the probability of X such that X equals to 1? So the answer here is 0.3. Probability of x such that x equals to 0. It is actually this one here. That's how we can express this kind of probability. And that's what it means by probability distributions. So we have this examination results and their corresponding probabilities. These probabilities should sum up to 1. So in this case, assume that scores are x. What is the probability of x such that x equals to 60? It is 0.2. What is the probability of x such that x is 80? This one here, it is actually 0.2. And finally, what is the probability of x such that x equals to 40? So 40 is this one, and so it's 0.1. So I want you to understand this logic. Here it reads probability of x such that x equals to a particular value of x, and values of x are 0, 1, 2, 3. So I takes all these values. Now let's look back to this kind of probability distribution we call probability distribution. Scores are distributed according to their probabilities. You can see that these scores are discrete, and therefore each one can be assigned probability. If we consider continuous random variables, you will see that probabilities cannot be assigned to a particular value, but to the group of values. We will learn about that later. So you should know that these are discrete values, and each one could be assigned probability. Assume that the scores are x, and so xi's are 98, 76, 50, and 40. So let me start here with a single probability. Probability of x such that x equals to xi. Now I'm going to go with a number of examples. Probability of x such that x equals to 70. I'm just picking up a value, 70. This one here. We know that the probability, if you put equal sign, and I'm going to skip here, is 0.2. 0.2. Let's look at something different. So what is the probability of x such that x is less or equal to 70? So here we are considering two things, equal and less. So that will be our values, which are equal or less than 70. They are 70 itself, 60, and then we have 50, 40, less or equal to 70. So what is the probability of x such that x equals to 70? It is 0.2. How about 60? It is 0.2. What about 50 here? That one also is 0.2. And what about 40? 40 is 0.1. And so we can add them. So in this case, I'm going to put equal sign and type sum of these probabilities. And so I'm going to highlight this, close the bracket, and enter. So we have 0.7. The probabilities of less or equal to 70 will be 0.7. Now, I'm going to show you something a little different. So what is the probability of x such that x is less than 70? So you can see 70 is excluded. So in this case, we're going to take the probability of 60, which is 0.2, and then 50, which is 0.2, and this one is 0.1. And we can sum put the equal sign and sum this. So we will sum what is less than 70, close the bracket and enter. We have 0.5. So in this case, you can see the difference here. 70 is included and here 70 is excluded. We are looking at the values less than 70. We could also find probability of x such that x is greater than 70. And in this case, you can see that 70 is not included. So we have 80, 90. Their corresponding probabilities are 0.2. These values are actually organized in a descending order. So we have 0.2 and here we have 0.1. So put equal sign there, sum. We're going to sum these two probabilities, and so the probability of x such that x is greater than 70 is 0.3. So let's try probability of x such that x is greater or equal to 70. So that means we're going to include 70. So we have 70, which is included, and then we have 80, and then we have 90. So in this case, we are going to look at their corresponding probabilities. So for 70, we have 0.2. For 80, we have 0.2 as well. And for 90, we have 0.1. So we're going to add, or we're going to sum probabilities, and so we are going to have 0.5. So that's how we can look at probabilities of greater or equal, or probabilities of less or equal. So we have a number of examples here. Now the next thing, we have this kind of values. So we could actually find average. We'd find average as we learned before, and also we would find standard deviation. So how do we find average? Just put equal sign and click AVR. So select average, and you can select all these values. Close the bracket, you will find the average, which is 2.5. And also we can find the standard deviation. So STD, standard deviation. I'm going to use this one. No, not this one. So I'm going to select this one here, standard deviation, which is this one. And it is the standard deviation, okay. So the standard deviation of these values. So we have 1.8. We could find average and standard deviation because these values are observed. Now, if these values are not observed, if they are estimated, we cannot find average and standard deviation the way we just did for the observed values. So let me pick this as well. Copy, and I'm going to paste them here. And these are estimated values, and therefore they should have their corresponding probabilities. So probability of x. So here we have 6, and let me try to put some probabilities there. So we have 0.1, and I'm going to put 0.1 also here, meaning that the periphery probabilities are always small. And I'm going to put probability here 0.3, that's 0.5 already, and then 0.3, and then 0.1, and let me give this one also 0.1. Let's sum the probability and see if they sum up to 1. So we're going to sum this. Our probabilities can sum to 1. So I just made up those probabilities. But all I'm trying to explain here is that we cannot find the average for the expected values same as what we did for these values. So what we can find here is what we call expected value of x. That's the average. And also we can find the standard deviation of the expected values. So we need to know the formula for expected value of x. Remember here, we just use the Excel function. And so how do we find the expected value of x? We have to follow the following formula. So it should be the sum of x times probability of x. If we can find the sum of x times the probability of x, that will give us the expected value. So to find expected value of x, x times probability of x, so that means I'm going to put equal sign here, click on this particular value times its corresponding probability. When you enter, we have 0. And I'm going to copy this formula way down because we are going to look at these values with their corresponding probabilities. And so I can copy this up to this point. And so now we need to find the sum of all those values. I'm going to put equal sign there, type sum, and we're going to add all this, close the bracket, and enter. So the expected value of x is 2.1. So how about standard deviation? So the formula for standard deviation of probability distribution of variable x is the square root of sum of x minus average, which is this expected value, to the power of 2 times probability of x. So here we have our x and we have probabilities of x. And then we have this as our average, which is the expected value. So I'm going to go up here and so I'm going to say x minus expected value of x, which can be written as mu. That's okay. However, that should be squared. So I'm going to close the bracket. And above number 6 on your typing pad, if you shift, you can find that symbol, which is to the power of 2. So let's work on that, and then here we will multiply by probability of x. So go down here. So we have x, that is our x. And so let me put equal sign there. So our x value will be 0. And it should be minus this expected value of x. And I'm going to close the bracket. And that should be to the power of 2. That's all we are actually looking for. And all we need is to lock down this value so that we can take all these other variables, all these other values, and they will refer to this. They will minus this particular value. And so all we have to do is to put the dollar sign here for this column G. Sorry, not G here, dollar sign. So put 2 dollar signs here. And we can now enter. So in this case, since we locked down this, we can copy the formula. So grab there, drag down up to this point. And so we have the x minus expected value. X is xi's minus expected value, and they should be squared. Otherwise, the summation will be 0. But now we are looking at times probability of x. So we'll take this, let me copy, paste it here, and this one, let me expand here, will be times probability of x, the corresponding probability of x. Put equal sign, click on this one, times probability of x, and enter. So since we're going to do all this with their corresponding probabilities, so it will be much easier for us to drop this down. And then we are going to find square root of the sum of this. So let's first of all find the sum. We'll write here sum. And that summation, put equal sign and type summation. So we're going to find the summation of all this and enter. But now we're going to look at the square root of this summation. So put equal sign. So we're going to find the square root of this sum of all those values. So enter. We have 1.44568,323. It is the square root of this summation of all these values which we have created. That is the standard deviation. And it is the standard deviation of the probability distribution of variable x. And here we have expected value, which is the average of the probability distribution of variable x. That's all we got here. So in this case, if you go to discrete random variables number 2, you can see that we have two questions there. We have the first question, which will ask you to find the expected value of x and also find the standard deviation. And I want you to complete this, and then you will submit the whole file, including the notes. Everything that you're going to work today, starting from the notes in this second part, will be submitted as well. In fact, even the first part. Will you please do this question as well? This is question number 2. Finish the first question, do the second question. That is your homework assignment. Now, if we can go to discrete random variables. So in this case, we try to flip coin, a well-balanced coin 3 times, and look at the chances of getting tails. In fact, I just picked the file which was submitted by a student. So let's flip the coin, and our x should be tails. So we're looking at the chances of getting tails, and we flip the coin 3 times. And I know that you have heard this example a lot of times. So when you flip the coin 3 times, let's look at the possibilities. So the first possibility can be tail, tail, tail. But also you can get tail, head, tail. Or you can get actually head, head, head. Or you can get tail, head, head. And then you can get head, tail, head. And then you can get head, head, tail. But also you can get head, tail, tail. And you can get tail, tail, head. So let's count this. Let's have 1, 2, 3, 4, 5, 6, and 8. So those are the possibilities of when you flip a coin. Those are the 4 possibilities that you can get when you flip the coin 3 times. So in this case, we're going to consider variable x, which is tail, and we're going to see at what time that we won't get tail at all. So will be 0 when we flip the coin. So when can we find one tail? I mean, just one tail. Or sometimes when we flip the coin, we can get 3 tails. Or some other times we can get 3 tails if we'll flip 3 times. So these are the possibilities. So let's look at the frequency or the occurrences. So the frequency, how many times when you flip the coin 3 times, you'll never get tail. If you look here, this one here, there's no tail, but all these other, they have tails. So let's say that can happen once. And then let's see, when we flip coin 3 times, what are the chances of getting one tail? So here we have one tail. Also we have one tail. Here we have one tail. So we have 3 chances of getting one tail. So what are the possibilities of getting 2 tails if we flip the coin 3 times? So let's see, here we have 2 tails, and 2 tails. So they happen 3 times. Now, what are the chances of getting all tails if you flip the coin 3 times? So there is only 1 here. So we're going to say only once. Once we have that, we can do a number of things. So we can find relative frequency, which will actually give us the probability. But that can be found if we know the total. So the total here can be found by the sum of these values. If you enter, you can see our total is 8. So 0 happened once out of 8. So I'm going to put equal sign and click on 1 divided by 8. We did this before. So you can see 1 divided by 8 is 0.125. And since we said probability is a value between 0 and 1 that can measure the occurrence of an event, so we can say there is 0.125 chance that if we flip coin 3 times, we won't get the tail. So you can see all this will refer to 8. So I'm going to double click there, put the $sign here by clicking F4, or by just typing $sign for both sides of this column G and enter. So now we can copy the formula way down up to here. So you can see we have relative frequency. In fact, they are probabilities. And also you can find cumulative probabilities. Cumulative relative frequency. So how do we find cumulative relative frequency? We did this before, but I'm going to repeat again. You just put equal sign. And so we have this one and enter. Cumulatively, then we're going to take this one plus this one here. So I'm going to put equal sign, and I'm going to sum these 2 probabilities. So that's the cumulative. This one is a cumulative of 1, of 0, and 1. So here we're going to add this one here as well. So sum, we're going to take all these 3 and sum all of them. we have 0.8, meaning that we are looking at the probability of having 0, 1, and 2. So finally, we're going to add this one as well. So I can do the sum of all this, or I can click on this plus this value here. That means I'm adding all this, and I'm going to add on top this one there. So let me click on this plus this one. So we are adding that. Or we could sum all those values, and so they end up into 1. So that's the cumulative relative frequency. We could also find the percentage relative frequency, or the percentage cumulative relative frequency. And so let me just find for this one the percentage So to get the percentage cumulative relative frequency, all we need to do is to transform these values into percentage. So I'm going to copy them. To copy these values, just put equal sign and click here on that particular value. So we just reference that number, and so we can also copy all these other values by dragging down. So we have just copied them. Now we're going to change this into the percentage. So if you click there, in fact, we forgot to add one more value, this one here. So you could also find the relative frequency, have this in terms of percentages, and or you can leave them as decimal points. Remember, they are still probabilities. So that's all with what we did in week 4. And I'm going to ask you to follow exactly what we have done and the exercise that we worked to, I just show you. If you can repeat doing what I've done, then you're going to submit that as your classwork assignment. Let me see how you are able to redo what I have done and see if you have learned anything. So thank you so much for that.